Okay, hello everyone. This is the additional video, hopefully, for your quiz preparation for chapter 6. So here's the questions. This is asking find the volume. So volume. This is two questions actually. So the first one A and the second one a B. This is from your textbook. You can also find in 6.3. Find volume within region bounded by the given curves, and then rotate it on specified line. Okay, the first one is rotated through x-axis, the second one is rotated through y-axis. Okay, so you can try first, and later we can compare our results. You can pause the video and check the results. Okay, so first, if we look at the functions or the equations, let's write down the equations. Y squared minus x squared equal 1. Okay, now what is this? Okay, what is this equations? Okay, so if you remember, okay, if we have x squared plus y squared equals some constant, like maybe 9. Okay, this is we call the circle equations, right? And if we have x over a plus y squared over b and equal 1, and this is the ellipse, right? The ellipse equations. So this is circle, ellipse, and the other one, if you have x squared, this will be a hyperbola, right? In our case, the equations start with y squared as a positive signs and negative x squared. This will result in this line actually. Okay, but since we have y equal to as our boundary, so we can just focus on one side, right? Okay, so if we draw, let's say this is y equal to, I think we need to make it a little okay, I think that way. Now the hyperbola, probably the hyperbola will be around here. Okay, as it is 1, so I need to make sure that it's crossing 1 here. Okay, now the first question is telling you that it's rotated through the x-axis. So x-axis is, this is x, y, so it should be rotated through here, which means that we will have, if we try to make a approximation here for our rectangle, if this is the x, then I will have a washer, okay, a disc with a hole. So this will be the inner radius, and this will be the outer. Okay. Okay. Now, before we start to calculate the volume, we can now find what is this x. Okay, so we need to find this x2, x1. Okay, that's fine. And let's write down the equations. Y equal 2, and then y squared minus x squared equal 1. So 4 minus x squared is equal 1, and x squared is 3. So we can have x is plus minus square root of 3. So this will be square root of 3, this will be negative square root of 3. Okay, that's I think our evaluation point, right? Okay, now since it's symmetrical, we can just focus on from 0 to square root of 3. Okay, that's our evaluation point. Then we can find the volume. Okay, we can find the volume. The outer radius is just 2, right? Just y equal 2. Okay, the inner radius is the curve, or the in our case here is the functions. Okay, the hyperbola functions. We can write in terms of y, or function of x. Okay, so y squared is x squared plus 1, or we can write down x squared plus 1. Okay, and we took the positive one, okay, because it's on the positive sides. So we can write down, let me just write from negative 3 square root of 3 so that you can see how it does. So this is 2 squared minus, this will be square root of x squared plus 1, okay, and then squared. And then let me write this, evaluate with the x. Okay. And this is resulting to pi. And let me evaluate from 0. And this will be 4 minus x squared plus 1. And we can compute this. It's become 4 minus 1 is 3 minus x squared. Okay. So we can have 2 pi 3x minus 1 over 3 x cubed from 0 to square root of 3. And we can input this. Oh, square root of 3, I think that, yeah. 4 square root of 3 pi. That's the first case, okay? Okay, now the second case, the same hyperbola, same curve, which rotate about the y-axis. Okay. I think I can make it around here. dy. And I think because we are using dy here, and this is pretty much the disk method, okay, and I think it will be much easier than this one. Okay, let me put this into here. Oh, wait. Let me put here. Let me put going here. Okay, that way. So the first one, so this is A and this is B. And the evaluations is from 1 to 2. Okay. And then pi. And then we can have the radius is x, right? This is x. So x is square root of y squared plus 1. Okay. Oh, sorry. Y squared minus 1, right? Okay. So that is our area and our radius, and this is, we can compute the area, and then we need to square this and then dy. So we will have 2 pi, and this will be y squared minus 1 dy. and this will result sorry, and this should be 1/3 minus 1. So this will result in 2/3. This one is negative 2/3, so plus 2, 2 plus 2 is 4, so it should be 4/3 pi. Okay, so this is the first one, and this is the second one. Okay, I hope you get the idea behind all these calculations, right? Okay, we can move on to the next question. We can try the this one. So suppose that we have a value of c, which is in between of 0 and pi/2, and we have the cosine x. Okay, we have the cosine x, y equal cosine x, and then we have y equal cosine x minus c, and also we have x equals 0. So these three will be our boundary, and it say that it is equal to the area of the region enclosed by the curves y equal cos x minus c, x equal pi, and y equal 0. So probably we need to draw the graph. Okay, I think we can draw. Okay, I think we can draw the cosine x. I think this is pi. This is pi/2. Okay, and let me take this as a line. Okay, this is x equal pi. And then we also have cos x minus c, which means that if you look at this cosine, okay, which means this is cosine x, and you move shifted c units to the right. Okay, so if this is the maximum of cosine 1, this point will be moved out and maybe around here. Okay, and maybe this will be our c units. Okay, that will be our c, and we are going to have the similar graph like that, and also this pi/2. So I will just focus on 0 and pi/2 to make it easy to follow. So pi/2 will we also having a shifted from pi over 2 to pi over 2 plus c. So we need to connect this line going there. Okay. Yeah. Let me write down here. Okay, I think that. And also we can just connect here. Okay, and now we already have all of our desired all the curves. Okay, the first one is cosine x, y equal cos x minus c, and x equals 0, which means we will have this is x equals 0, right? This red line. This is cosine x, and this is cos x minus c. So this is area A. So if this is area A, okay, so this will be area, or this is area A. Okay. The second one, okay, the second one should be cos x minus c, x equal pi, and y equal 0. So this is y equals 0. So this should be the area. So my drawing seems not really proportional, but from what the information was given, this area should be equal, and it's asking what is the value of c. Okay. Okay. First, we need to make sure. What is this point here? From my picture here, it seems it's c over 2, but we can confirm through the cosine x equal cosine x minus c. So we can confirm this if x is c over 2, if looking at the point, okay, and we know that this is positive because of the cosine, the quadrant 4, that is true that the x is c over 2. Okay, now when we look here and we want to calculate the area in between of those curves on area A, we can write down the area A as integrations from 0 to c over 2. So area A, or let me just erase this, and area B is, and it should be equal with area B. Area B will be from this pi over 2 plus c, we need to evaluate until pi. Okay, so this will be the area, and then integrations from pi over 2 plus c until pi. And the integrations will be just the cos x minus c, but it's on the bottom side or the negative parts of the curves, so we may need to make it a negative form, and then write down cos x minus c and then dx. Okay, we just integrate as usual. So let me integrate this. Cos become sine x minus sine x minus c from 0 to c over 2 equal, okay, this will be negative sine x minus c from pi over 2 plus c until pi. Okay, we can calculate slowly. We calculate slowly. And for 0 part, we still have 0 minus sine minus c, okay? And then it's equal minus sine pi minus c, okay, plus or minus minus, okay, sine pi over 2 plus c minus c, okay. Okay, now carefully we write down this part. So minus sine minus c over 2. This part itself already minus sine c over 2. So minus and minus become positive. So sine 2 sine c over 2, like that. Okay. And then this will be positive, right? Because it's already negative, negative, positive, so negative sine c, okay? And it's equal this is cancelled and this is 1, right? And pi minus c is just, so sine pi minus c is just sine pi minus c, so it's just negative sine c, okay, if you remember the property of sine in trigonometry, okay? So that is, and we can cancel this, so we have 2 sine c over 2 is equal to 1. So sine c over 2 is half, and we know that this is precisely if in the first quadrant, this will be resulting pi over 6, okay? So c over 2 is pi over 6, which is c is cancel, so this will be pi over 3, and this is our result. Okay. Okay, we can move on to another one. I hope you don't get confused on here. The idea is we need to make sure that our graph is okay. We find the intersections, and then we can imagine how the area looks like, okay? All right. Okay, move to the next one. Let me check the other one. Let me check. Oh, I think this one. The figure shows horizontal line y equals c intersecting the curve. Okay, the curve as you mentioned, as you see from the picture, and we need to find the c. Okay, the c. Okay, actually it's quite easy to follow, but it's needs some writing. So I hope you get the idea here. The key here is that the area of the shaded regions are equal, which means if this is A, this is B, A and B is equal. So we can write A is equal B, okay? Now, to make it easy or simplified. If we take this intersections and this intersection as some point A to B, okay, as the intersections, then we can write down from 0 to A, we can have our integrations C minus the curves, which is 8x minus 27x cubed, okay, and this is the x. It's equal integrations from A to B. Let me write this around. Okay. This is equal with 8x minus 27x cubed and minus c, and then the x. Okay, let me change the color. So first, if we look at this integration, we can integrate easily. Cx minus 8 divided by 2, 4x squared, plus 27 over 4, x with power of 4, 0 to a. And this equal 4x squared minus 27 x with power of 4, okay, and then minus cx from a to b. Okay, then we can just follow up all the informations. So ac minus 4 a squared plus 27 over a with power of 4, and the 0 one will be just 0, and this one have 4b squared let me just write all. Okay, I think that's enough. Okay, let's try to solve this. Okay, let's try to solve. This minus 4a squared is cancelled. And plus 27 over 4 also cancelled. So this is plus 27 over 4. Also cancelled. AC plus AC is cancelled also. So all the one on the right now it's cancelled. So we have 4b squared minus 27 over 4 b with power 4 minus bc is 0. Okay. Okay. Now how to solve this? Now look at C. Okay, C is on the line here, right? This is y equals c. So we can also imagine when c is at that y, we can also compute this in terms of b. So we can exchange when x equal b and y equals c, we can write this as our equations, right? Okay, so let's do that. So we can write down okay, let's solve this. oh sorry, this is squared, so we have 4b minus 8, so we will have minus 4b squared. And this will be plus 20, this should be plus, okay, plus 27 over 4 so minus, so 4, this is plus 108, this is 81 over 4. So we can have, let me write here, 81 over 4 b with power of 4. Oh, let me write this down here. So we can have b squared as a factors. Okay, this is equal 0. And since b is a positive, right, and b squared is 16 over 81. Okay, so it's from here so b will be getting 4 over 9. So c is 8b minus 27 b cubed, or we can compute with b. This will result 32 over 9, 64 over 27, and this will be 32 over 27. Okay, now that's the results. Okay, now I hope this is helpful for your exercise, and I think I will make another one maybe in a few weeks, few days I mean. So hopefully you guys can have some exercise, okay, for your chapter 6. Okay, and in the next few days I think I will combine most of the review, okay, either chapter 5, 6, 7 for hopefully final preparations. Okay.